So, 3 o'clock. Thank you for joining, everybody. We're very happy with over 140 participants registering to welcome you today on our webinar around innovative CT, computer tomography systems, and 10 years of user experience. And I'm very, very happy to have two guests here with me today. Jochen Butzer from Bosch will... Hey, Jochen, great to have you here. Will give us a nice presentation about how computer tomography is being used at Bosch and all the great things that they have done with this over the years. It's a very, very insightful presentation and giving a lot of little pro tips away how you can also improve your CT operations. And then with me as well, there's Benjamin, who is my colleague from Diondo, and explaining more about how diondo is building the best CT systems in the world with the highest amount of flexibility and the latest, greatest new innovations, and maybe, Benjamin, even a little sneak peek on what's going to happen next year. I heard Jochen has a little Christmas wish, so let's see if that's going to be fulfilled. So, with no further ado, let me share my screen and have a little intro before I hand it over to the experts. So we are the VisiConsult group, Diondo being part of this group with their CT systems. We are globally active with over 300 employees worldwide, headquartered in Germany, Diondo in Hatting, us in Stockelsdorf, close to Hamburg, but then with subsidiaries in the Americas region, in Atlanta, or all over the US, where we have roughly 16 people, service, applications, sales, support. Then we have our VC India operations, where we have, I think, roughly 8 or 9 people, plus some partners to support our local customers in India. And then we have employees in China, in Brazil, in France, and in other areas. And most importantly, and I see some of our partners are here, joined us for this webinar. That's great to have you here. We have over 60 channel partners that can support you with whatever CT or X-ray need you have in your country, in your local language, and also can help with servicing these machines. On a group level, we'll focus a lot about, let's say, CT systems and mostly standard. And Benjamin will show a little bit of customized CT systems, but a lot of them, like really, what can you put into your lab to have a high resolution, premium scanning system? But we as a group, we do more. We do 2D systems, shop floor systems, hybrid CT 2D systems, automated systems, customized solutions, integrated systems into manufacturing lines. We'll not talk about this so much, but also there's great customized CT systems that we have built and can build as a group. And then software solutions and a big service offering from on-call services, availability packages, spare parts, and much more predictive maintenance that we offer our customers so that you can get the most out of your solutions. And if you really love what you heard about CT, but you're like, I don't think my boss will approve buying a CT system yet, then there's good news, because we are also offering probably the biggest inspection services offering in the world. We have CT systems and 2D systems ranging from nanofocus all the way to a linear accelerator, 6 MeV. We have one of the biggest scan facilities in Europe with 2 bunkers that we can use. But we also offer 2D X-ray services, PT, VT, LT, MT in our service offering. Our inspection services group helps with consulting and system purchasing. We do remote evaluation. So if you have a CT system, but you don't have enough, let's say, volume graphics experts to read all the data, send us the volume. We can do the evaluation and send you a report. Also, we help with trainings, whether it's CT or X-ray, technique development, volume graphics, macro development, AI, level 3 services, and even ISO 9712 certified training courses. So that was the boring part. Now I'll hand it over to the fun part, and that is Jochen going first, giving us the practical insight into what's going on at Bosch. And thanks for being here, Jochen, today.
Yeah, thanks a lot. Thanks for inviting me. You may know that tradition of a Christmas lecture that is held at universities typically just before the Christmas break, and typically experiments are presented. And today I would like to present to you also some experiments that we did and how we did them. And this is, yeah, in a way, that tradition. I'll first explain you about what equipment do we use to perform those experiments, and then I will talk about some of these tricky things that you might not be sure if it's possible to perform these experiments for large parts, for very small parts, or also when parts are very dense or we have a huge number of parts. Those are those special cases that I'm going to talk today about. And finally, I will talk a bit about current topics and an outlook of what we are working with together with diondo currently. So let's start with our system and our team, because what I'm going to present is not my only work. It's a work of the whole team. And those people, we work together with that system. And the system is a diondo D5 system that we have just installed 10 years ago, roughly. And it replaced our 1998 model of one of the first industrial CT scanners worldwide that we've been operating in our department. We had to replace it because we moved to a new location, which is shown down here. It's in Renningen near Stuttgart, and we were not able to ship the very old CT system to here. So we were very happy that diondo offered us such a great system with a walk-in cabinet, which makes it possible for us to do some extended setups, for example, high and low temperatures, or other possibilities of bringing cabling, liquid air, whatever, inside the cabinet. It is operating a 240 kV microfocus tube, and initially was equipped with a 2K and a 4K detector. And about 4 years ago, we upgraded this to a 3K detector, which I would say is one of the best compromises between data quality in terms of resolution and file size in terms of what I have to have as RAM and the computer to visualize the data. The system also has a mini focus tube and a line detector, and I will show you some of the applications that are possible with that setup. But now let's start with the first experiment today. It's a bike. And maybe for those who are not so familiar with CT, I will spend some words on how a CT is working. So here we have an X-ray tube on the left side of that image, and we have a detector on the right side capturing X-ray images. Now, this is the object mounted on a rotation stage, and this object now moves. First, the saddle is in front of the X-ray tube, then towards the wall, passing the detector just closely, and then going again up to the X-ray tube. So this is why large objects are sometimes hard to mount, because first of all, this has to be mounted on this tiny rotation table. Then it has to be able to rotate the full 360 degree, and all this has to be stable and precise. Now, the result you see here, it's a CT slide from the reconstructed 3D data set, and it's just a cut through it. And you can see here some of the belts, they are jammed here between the gear wheel and the housing. Some of them are spread open here and split up. And yeah, you see that is the reason why this motor is not working anymore. And we could identify this reason without having to open anything on that bike. We could just use it as it was. Maybe here, just for you who are familiar with 2D images, in CT, the white parts are the metal parts, and the lower gray, darker areas, those are the areas of plastics or rubber or anything. Okay, for a long time I thought, wow, this is the largest object that I will place in my CT system. But then came some people with a van door. And we at Bosch, we built the window lifter system. Here on the right, you can see some series of still images in an animation that show how this window lifter system is working. It's a small motor that carries the window up and down. And this was special because it was large. It was also special because they wanted to show it live in motion. So we were placing a controller next to it, cabling it, and placing those cables so that they can be controlled from outside. And we could just make this nice X-ray video where we could see the motion, the wires and the things moving inside of that large door. And that was already amazing. We also did some subtraction of the images from start and end positioning. So in white and in black, you can see parts are moving a bit. And we were happy, and the customer was happy at first place. And then he realized, but this is a CT system. Can't you do a CT as well? So we tried this. And the challenge was that this large door brought the rotation table to some oscillation due to the asymmetric load and the high load that it had. At that time, I was not willing to give up yet, so I gave a call to diondo, to Nabil, and he adjusted the parameters of this motion controller SPS, and he was able remotely within half an hour to adjust those parameters so that we could control the axis and we could measure this completely. The full van door was scanned, and the area in the middle where the motor was visualized. And I can show you this in an animation of the, well, it's a sweep through the 3T data. You see, maybe you can see it here on the right top corner. We have a horizontal cross section, and the yellow line is the line which is visualized here in the full screen. So we have overlaid in red the CAD data. The CT data is the grayscale images. And we are now moving at other different positions just around that shaft. It's a radial view that we move around that shaft. And you can see it's possible, and we can really see all the details inside, match them up with the CAD drawing, and yeah, visualize all that. And it was really the largest thing that we had in the CT system. So now to small things, because it's not obvious that when a rotation table is capable of such heavy load, that is also capable of a high resolution. But you can see here with that 5 micron voxel size scan of a press fit pin and this printed circuit board around it, that we are also able to image very small details. We were comparing in this study the contact surface areas of those pins in an unrolled view, and we were also creating a 3D model using Geomagic from the printed circuit board and the pin itself, which could be used for simulation purposes. So also very small and fine details, it's just a very tiny thing, are visible with our CT system. So now some things are medium sized. Let's say this is the size of a football, and they have another challenge. They are very dense. So this part contains mainly steel and copper, things that are shielding the X-rays a lot, and we have trouble visualizing them. If I would image this with a conventional 240 kV tube, I would just see foggy because we're not able to really penetrate through the image, through the object. And also, if I would just use a conventional detector, I would have a lot of scattering artifacts, which would not make it possible to evaluate that thing very good. So this is why we use a line detector for this. A line detector has a collimation. That means he just imaged one plane where the X-rays pass through the object, and then this is we have many of those reconstructed slices stacked on top of each other because we scan them individually. Now this scan has one drawback. It takes 24 hours to complete here in this case. But when it's completed, we can have a good insight into a dense part. This is an electric air compressor from a mobile hydrogen truck application. And it's possible now to evaluate things inside, such as the mold mass or the contacts, other things. Now, as I said, 24-hour scan time is something you can do with individual parts, but not if you have more parts at the same time. So because this was an important task for us, we also evaluated other methods, and we used the equipment at diondo, the service equipment they had, to evaluate how this could be speed up. And it was possible with the mesofocus tube, for example, in 1 hour scan time to show that mold mass really in very good quality. And also the linear accelerator was very fast scan here we did, could show, for example, those wires in a very clear way. And so we now know, okay, if we cannot scan many parts in the given time, we are able to go to diondo and have this as a service. And this also led to the purchase of a system in Reutlingen, which included the mesofocus X-ray tube. So we now at Bosch have the possibility to use the mesofocus tube as well. Now, this was a special request. The special thing about it was that we had to investigate 9,000 parts. 9,000 parts is something, typically one part takes 1 hour to image. So 9,000 parts to image with a CT is normally not possible. But I can show you how we did it. First, let me explain the problem we had in these parts. So you can see here, those are metal discs. They're placed in this blue area of that electric fuel pump. And we have a hole by error punched too deep. So there was material missing here in this part. And on the normal parts, it was existing. So we had to identify this. It looks easy, but in a CT, it looks like this. And from just one cross section, you're not sure if that scan was slightly tilted, and you might have missed the material here. So we decided to measure in 2 height sections, so 2 CT scans, one above the notch and one centered at the notch. Now, I can show you how this looks like. Maybe on the right, you see here, this is above the notch. We have a hole on a gap on every one of those notches. So there's a gap, and now it closes for most of them, but for this one, there's still a gap. So this is the NIO part that we had to identify in order to make a reject or accept test for each part. Now the aim was to do that in short scan time. And here are the parameters, maybe just the summing up. We used 2 height sections, and we could scan 22 parts in 2.5 minutes scan time. So overall, it was like 4 to 5 minutes cycle time, including the loading. And that was the result, how we could maybe make it possible to scan those parts. From the arrangement, we didn't use them in a block. We used them in a circular arrangement, as you can see here. And we had 4 team members working simultaneously. One was doing the organization of it. One was operating the CT system. One was loading parts and unloading parts constantly. And another one was doing the evaluation. And we really had to switch this position after 1 hour, because it's very tiring for the eyes to look at those things and be precise. And we did some regular checks for concentration by using not IO parts in between without telling that person, and checking if that was found. So we made sure the concentration is still there. And with that, we managed in 6 days, only 1 shift, no extra shifts over weekend or so, just no night shifts, just 1 6 days shift. And we scanned a lot of scans. In total, it was 9,006 parts scanned, and 6 parts were not in order. All the other parts could be delivered. And that was one of the reasons why we did this. The customer said, we have to deliver. And with our CT evaluation, we could deliver the parts very fastly. Now, I talked a lot about experiments, tricky things. I will talk now about software, also for tricky cases, because this software can make things possible that are not possible with a conventional system. I talk about Voxray. It's a startup, and it has dubbed its method quantum CT reconstruction with the aim of modeling just a physical principle behind the CT without the use of AI. Now, how it works is basically we have a physical model, and this model produces simulated projection data and compares it to the measured data. And it optimizes itself by iteratively, well, minimizing this misfit between the two, measured and simulated. And the resulting model represents that data set that we get from a reconstruction. But it has a large reduction of artifacts, which makes it especially interesting for multi-material data sets. We can better distinguish between the materials. We have low noise on the surfaces and no blooming between neighboring layers. And I will show you some of these results. I've chosen a study. On the right, you see always the Voxray data. It is the same. It's one of the first images we got from Voxray in 2023. And on the left, I will show you some different CT reconstruction algorithms that we used in a study together with a friend of mine, Sven Gontrom-Linke. And this was optimized by the hardware vendor, by the software vendor, sorry. So it was not, the parameters were not chosen by ourselves, but by the vendor. So they represent the optimal that was possible at those days. We also compared this impartially with current software, and the result is still the same. A little spoiler, Voxray is always better. Now, what is better? You can see here the material discrimination. You can see very fine details of small materials. You see almost no artifacts, and you see a clear separation. And now here it's just a standard filtered back projection. Okay, you can say this is normal. It might not be the optimal. So now let's use some scatter correction algorithm on it. And it does get better, but it still doesn't keep up with Voxray. Also, algebraic reconstruction techniques are used in a way sometimes, but they don't produce better results from our study than Voxray. We used, for example, also software from a visualization company. We used software from a spin-off company. And we used software from a company in the US. Also, algebraic reconstructions. And finally, we went to the detector vendor because they can make a scatter correction based on the scattering inside the detector. And even that was not as good as the Voxray data that we got. So that was the reason why we continued a lot of collaboration together with Voxray. And maybe here you just see, again, from the same data set, a vertical cross-section and also a 3D rendering to just see that surface quality, which is possible. Now, as Lennart already mentioned, I have a Christmas wish. And my wish is that this Voxray system will be implemented in the DI control. So currently, I have to close my reconstruction server and run the Voxray reconstructions overnight or overday, but then I cannot reconstruct anything else. So my wish would be that I can choose as a user which reconstruction I need and how I want to prioritize my reconstructions so that there's a batch processing of reconstructions in the pipeline. Especially in terms of GPU allocation. This is important. And Benjamin already promised me there might be a chance that next year this wish will be fulfilled. So I'm very much looking forward to that. Another thing, a Christmas present, which is just about to arrive for me, is an XY stage. Maybe I explain to you the problem that I have, or the idea. So I sometimes want to measure overnight or over weekend many samples because, as you know, sometimes I have many samples that arrive, and I stack them one over the other. Um, and I want this stack to be measured at each height section individually per part. So typically this is a compromise because my stack is often tilted. It's not perfect aligned. And I can just choose one position, and then some of them are a bit to the side, others are not centered. So my compromise is typically on resolution. I'm not able to measure them all perfectly. Now, this upgrade will allow me to install a battery-driven XY stage, and implemented in diondo is a position that I can choose for each scan height so that this XY stage positions the sample at the correct center and measures that whole stack overnight, over weekend, without any compromises. And this is something special because no other company, to my knowledge, offers this implementation. So you can buy that stage from other companies as well. But to have that implementation really makes a large benefit to us users, and that's very helpful. Now, one of the last things I want to talk today about is we have a working group on radiation dose sensitive electronic components and devices, which is headed by Olaf Günewig from diondo. And together we are discussing on dose measurements, on creating some guidelines. It's not only automotive applications, but also aerospace companies are part of that collaboration, and it's very helpful to discuss and to have that framework within the DKE group to talk about those things. Now, as a summary, I'm very happy that our flexible CT system is not outdated yet. Even after 10 years of operation, I feel like we still have a very good system. And we've also proven this by round-robin tests within our company. We're still on the top 3 of systems, and we have more than 30 systems in the company. Many non-standard CT requests empathize that we have one of our role is an expert for special tasks. We don't do only special tasks, we also do normal things, but we're a bit the experts for those special things. And thanks to an optimal support that we got from diondo, we were always back in operation in short time. And maybe a short story, it was a few years ago when our board of management was asking us to scan a part over the weekend. And that was not so easy because our line detector always produced some black lines, and we were not able to solve this on Friday. And I called diondo Matthias Helling, and he said, okay, I typically don't call him that urgently. And I explained to him, it's the head of management, board of management. I really need this. And he said, okay, I'll talk to my wife. I'll skip dinner. I have this ready for you. I'll do an optimization of your program. And he managed to repeat those lines of black disturbances. And so that scan was running smoothly over the weekend. And on Monday, we could give the part back as promised. And we had the full data set perfectly made available to us. This was really special commitment, and I was very happy about this. And so due to that good relationship that we have with diondo, I'm sure we will explore many new areas in the future and have a great time together. So thank you for your attention, and I'm very happy to answer questions in the end.
Jochen, thanks a lot. That was an incredible presentation. I already had the pleasure. Yeah, I saw a round of applause. Thank you to all participants. I already had the pleasure to see that presentation, our Technology Day live. Oh, wow, and see this, Jochen, you're getting a lot of positive feedback. That was very, very interesting. Thanks a lot. There were a couple of questions. I'll keep those towards the end because now I want to hand it over to Benjamin, who will give us a walkthrough through all the systems that diondo is able to do. Well, maybe not all of them because those would be too many. but he will do a good job in giving you a nice understanding and all the things that are possible. And then please hang in there because the questions will be answered towards the end, and we'll have some time to go into a little discussion. And Benjamin, with that, I hand it over to you.
Perfect. Yeah. Thank you very much. Welcome from my side as well. It's really great to hear how we've been supporting Jochen from Bosch with his CT system for more than 10 years now. And the best part, the system is still fully state of the art. That's a great example of what we believe in. CT systems that don't get old, they just get better. On the next slides, I will show you a few of more highlights from our systems, explain how all of this turns into everyday benefits for our customers. And we have already learned a lot about the company and about diondo itself, so I will just skip the company intro and jump straight to something more exciting. So one of our key tools, and honestly, one of our secret weapons is our industrial CT scanning service. We operate an incredible fleet of systems ranging from micro CT all the way up to XL Linac CT. And why does that matter? It's simple. We don't just build CT systems, we use them ourselves every single day. We exchange ideas with other users on a regular basis, discuss features, workflows, and improvement ideas, and feed all of that experience straight back into system development. Probably our biggest advantage, and yes, our real USP, is how insanely configurable our systems are. But let's be honest, everybody claims to be flexible, so what does that actually mean for us? Driven by innovation and a constant search for more reliable and powerful components, we've integrated more than 27 different X-ray sources over the past 10 years. Add to that over 16 digital detectors. And just when you think that's enough, our manipulators and motion concepts come in more than 23 different variants. So configuring CT systems doesn't stop at the beamline, not even close. We're talking about in situ stages, both our own and third-party systems, automatic pre-filter changers, ultrafine positioning tools for the smallest samples, as we have seen at Jochen, and even tools for continuous logging of temperature and humidity inside the radiation enclosure. But there's more to discover, especially when it comes to automation. So for overnight or weekend operation, motorized part changers can be integrated, allowing small series of parts to be scanned completely unattended, while everybody else is enjoying the weekend. And those solutions are available for multiple of our CT systems. So no, customization isn't a marketing buzzword, it's really our philosophy. Everything, this is good news, is fully controlled from one single software platform, the DI control. So our software developers have done an amazing job, and luckily for our customers, they are still not done. Every day they make the system faster, smarter, a little bit better than the day before. And here you can see an overview of the CT systems we consider as our standard today. And standard really means the full range from ultra high resolution all the way maximum to maximum penetration power. So whatever your application looks like, the chance is high that you fit right here in this kind of table. Our CT systems are built on ultra-precise granite, delivering outstanding accuracy and rock-solid long-term stability. Combined with precision lead screws and encoder-based drives, recalibration and homing of an axis become a thing of the past. This makes daily operations safer, easier, and more efficient. And this is where it gets interesting. Every system includes an adjustable focus to detector distance as standard. It's one of those features that completely changes how you work. And in a moment, you will see exactly why. So here you see an exceptional detailed scan of a coffee bean acquired on our D2 system at a resolution of just under 5 micrometers. It's an excellent illustration of the level of detail achievable with high-resolution CT systems today. So how we can actually use a variable focus to detector distance to our advantage. We scanned the same coffee bean with 3 different setups to show how changing the distance directly affects the scan time. Just a quick reminder, physics is on our side here. If you halve the distance, the dose rate increases by factor of 4. And this is exactly where the advantage of the variable FDD becomes visible. while the CT system with a fixed distance of 800 mm requires up to 4 hours, reducing the distance to 300 mm cuts the scan time to just 34 minutes. And at a distance above 1.5 meters, let's just say patients become a key requirement. So here's a second example. This time we used a lithium-ion cylindrical cell scan at a resolution of 63 micrometers. And what's interesting is that the image quality stays exactly the same. No additional detail, no hidden features. The image may look the same, but the scan time definitely doesn't if we change the focus to detector distance. By increasing the FDD, the scan duration jumps to almost 5 hours, more than 3 times longer. So this is a great example of why a variable FDD really matters. It allows you to choose the most efficient setup for the task at hand, without wasting time and without compromising image quality. Let's look at one final example to illustrate this. A power tool battery, exactly the kind we use every day in our own company. For me personally, this is really a highlight because it was scanned using our latest edition, the 320 kV microfocus X-ray source, combined with the optimized reconstruction workflow that we already had heard at the speech from Jochen today. So have a closer look. The result is a powerful mix of penetration, resolution, and image quality, a great example of what modern industrial CT can deliver today. And let's compare the scan times. Even with optimized parameters and adjusted reconstruction, there's still a time difference of 4 hours at comparable image quality. Or to put it differently, while one system is still scanning the very first battery pack, the other one is already running the 5th scan. Now that we've explored focus to detector distance, let's turn to another crucial factor in CT system optimization, selecting the right source. From day one, we believed it's better to work with the best than to claim to be the best at everything. So that mindset gives our customers exactly the components they need. When it comes to X-ray sources, that means real choice of microfocus sources, robust mini focus sources at 450, 500, or even 600 kV, and high-resolution mesofocus tubes designed for maximum availability. At the end of the day, it's about one thing, giving you the best possible tool for your job, not just the one we happen to have. For our micro CT systems, this means real freedom of choice from market-leading 320 kV reflection tubes to nano-focus sources up to 240 kV, or combined in one system, both tubes. So no compromises, just the right source for your application. And here's something many people don't expect. Why buying 2 X-ray tubes if one can do the job? So let's have a look here. Our ultimate solution for an extremely wide range of application is a 240 kV transmission tube, as used in our D1 systems. This tube delivers 50 watt, and to be very clear, we are not talking about emission power here, but effectively usable target power. That's what really counts in practice, and it's what allows this source to combine high resolution with impressive performance in one single solution. So when do you actually use a transmission or nanofocus source? If we look on this image, the difference becomes immediately clear. On the left side, you see the slightly blurred results of a reflection or microfocus source scanned with a resolution of roughly 5 micrometers, which is essentially the resolution limits of this technology. On the right side, you see the results from a classic transmission or nanofocus tube, here at a resolution of 1.7 micrometers. The edges are razor sharp, the details are crisp. And because nanofocus sources typically offer only limited voltage and power, many users assume they are not suitable for classic microfocus applications. That assumption makes sense, but it doesn't apply to our high power version. To prove exactly that, let's take a look on the following scan of a lithium battery. Both scans show nearly identical image quality, but the transmission curve can be faster. Even at 50 watts, it still delivers 15 micrometers resolution. Proves that high resolution and real power can really go hand in hand. So, and already I explained about our new feature, the new tool in our product family. It's really the highlight of today's webinar, the official introduction of our new 320 kV microfocus source, the most powerful open microfocus that we use in our CT systems. It delivers an impressive 450 watts of usable target power at 320 kV, and it can be used for applications down to 4 micrometers. And the best part, no cool down times, no hidden limitations, none of the typical restrictions you often see on the market. Let me show you 2 examples that clearly highlight the advantage of this tube compared to the classical 240 kV version. The first example is a direct comparison of the rotator using a complex casting part. In the more challenging material regions, you can see still artifacts at 240 kV. With identical scan times, increasing the voltage to 310 kV significantly reduces these artifacts. This is a perfect illustration of how higher energy directly translates into cleaner data, especially in demanding applications. Another great example where the 320 kV tube clearly showed its strength is this power tool battery, which you may already recognize from our discussions on the focus to detector distance. This time we are looking at a direct comparison against the current market standard of 230 kV. This power tool battery is actually quite a demanding multi-material component, and this exactly is where the 320 kV source can really play to its strengths. The contrast is stronger, metal artifacts are significantly reduced, and keep in mind these images were taken during an initial test run of the source without any further optimization for scan time or image quality. So this is really just a first impression, but already a very convincing one. And as final example, let's look at something, let's say, a bit unexpected, scanning a classic aluminum cylinder head. Not with a mini focus source as usual, but with a microfocus tube. Why not go for 320 kV? Even so, this may not be an everyday task. It's a great example of the versatility of this microfocus source in real-world operation. This example was scanned using a well-balanced compromised routine scan time and resolution. Of course, the advantage of this tube in terms of resolution can be pushed even further, but if you're willing to invest a bit more time, that's fine. So far, this kind of image quality was quite impressive for us. Because we typically don't use a microfocus for this kind of applications. If scanning a very dense material is a frequent requirement in near production environment, it's definitely worth taking a closer look at the following tube. The major focus source is widely known and the go-to choice when availability and true 24/7 operation is required. Its unique combination of high resolution, strong penetration power, and maximum uptime. It makes it first choice for demanding near production environment. With our CT systems, you don't necessarily have to choose between high resolution and high power. In many cases, as you can see here, the combination of 2 450 kV sources is actually the best solution, allowing you to select the right source depending on the application. So what we can see here from the image is a comparison. On the left, the major focus with 450 kV, where we have a 30 micrometer scan and a longer scan time, but with a very nice resolution compared to the classical high power source that has done the scan in 12 minutes. But do you already know the little brother of the 450 kV source? So there's a new 225 kV mesofocus now available with a resolution of 15 micrometer at an impressive 50 watts that is significantly expanding the range of application. In addition, a second focus spot with 40 micrometers is available, delivering up to 150 watt. And when availability, resolution, and speed are the key requirements, this tube is a perfect choice. One practical use is, of course, a battery cell inspection. As this example shows, the mesofocus source enables exceptional short scan times. At comparable power levels, classic microfocus tubes would already start to defocus. As a result, the power has to be reduced, leading either to longer scan times or increased noise. Of course, there are also open tubes with specialized designs and advanced cooling concepts that can still keep up in certain cases. However, when maintenance intervals and downtime for filament replacement are taken into account, the closed mesofocus clearly takes the lead in this example. As so often, it's not about good or bad X-ray sources, it's about choosing the right one for your application. So we have now talked quite a bit about the capabilities and advantages of CT systems that can be configured precisely for the intended application. Now I want also to introduce some of the, let's say, more special things. So finally, I would like to show you examples of customer-specific solutions with different levels of complexity. They clearly demonstrate one key message. For almost every requirement, there's an optimal CT solution if the system is designed the right way. So let's have a look on the first example here. It's highlighting our D3 platform that can be transformed into a dedicated CT solution for testing large battery modules. Here in this case, there are some modifications, increasing scan height, higher loading capacities, a special L-shaped door, loading crane extended loading axis for safe and ergonomical handling, and a dual 450 kV configuration for maximum penetration and high resolution. And this clearly shows how targeted adaptations can significantly optimize the workflow. So the second example is one of our most exotic solutions, what we call the glove box CT. Most people know glove boxes from Hollywood movies where dangerous viruses are analyzed behind thick glass and rubber gloves. But in reality, glove boxes are also used for materials that are extremely sensitive to the environment. And if you want to scan exactly those materials using CT, that's where our glove box CT comes into play. This system is a true one-of-a-kind solution and strong example of how customer-specific engineering enables advanced research application without compromising safety or material integrity. And finally, I'm very pleased to introduce our gantry solution. It was developed especially for long objects that either cannot be inspected vertically at all or only with a significant effort. Typical examples include drill cores, helicopter blades, even rockets, but it can also be applied to very special cases such as mummies or its sarcophagus. So here we see how the machine is working. The key idea is simple. Instead of forcing the object into unfavorable position, the system adapts to the object. The slide shows the schematic workflow, underlying principle and motion capability of the solution. It is available with multiple different X-ray sources and can be customized to meet individual requirements. Beginning early next year, one of these gantry CT systems will be on display at the new National Museum of Korea. And this brings me to the end of my presentation. I hope I was able to give you a brief insight into the wide range of configurations and solutions we offer. We talked a lot about hardware today. I think in our next webinar, we will focus on the software side and its functionality and features. Before that, let me summarize the key points. The variable FDD allows us to find the optimal balance between scan time resolution and penetration. With high kV transmission tubes, we offer an attractive alternative to dual source CT systems. The latest 320 kV microfocus technology enables shorter scan times and fewer artifacts and opens up applications where conventional microfocus tubes reach their limits. And finally, where throughput and availability are key, mesofocus tubes are the right choice, delivering reliable performances with resolutions down to 50 micrometers. Taken together, this flexibility enables us to tailor each CT system precisely to customer requirements, both today and in the future. So thank you very much for your attention here, and let's configure the right CT solution for your applications.
Thank you, Benjamin. Let's give Benjamin a hand of virtual applause here. My head is spinning, Benjamin. There is a lot of complexity in that flexibility as well. But hey, that's why you reach out to experts as you and us to guide you towards the right solution. So while I will go into the question section, this gives the opportunity for everybody who still has a question to submit it to the Q&A section or to the chat. There were a couple, and I will start to read through them. But please continue to drop your questions as you go. I'll go start with the earliest one. And that was John asking if you're able to provide more details, what iterative algorithm is being used, MLAM, TV, ZERT, CGLS. I'm not sure, Jochen or Benjamin, if that is a question that you are able and comfortable to answer, but if yes, please feel free to elaborate a little bit more on the reconstruction side.
So I think John is asking for the Voxray, I guess, on the Voxray algorithm, which is an iterative algorithm, yes, but it's different to those in terms of it does mimic the real physical world behind it. So it solves the multi-energy Lambert-Beer equation, and that's why it's also so good in doing multi-energy reconstructions. That's what I can say. For other questions relating to that algorithm, you would need to contact the persons directly. It's Voxray. Darius Rückert is the CEO that will surely be able to answer some of the questions you might have. If the question was rather on the other algorithms, yeah, maybe just ask us a separate question if I haven't answered it yet. No.
Benjamin, is there anything that you want to add on this?
I think that's perfectly a summarize of what I would also recommend. The experts, as mentioned, that can give you a detailed overview about the algorithm used or how this works. So I would recommend to have a direct contact with them and discuss these topics.
And John, I would encourage you to reach out to Shane, your local contact in the US, to ask for more information. The Voxray software is integrated, so we can provide it as part of the system. So you know where to find us to get more details being asked. And this is part of the flexibility. Diondo or the VC Group in general, we have nearly every available reconstruction package on the market, at least somehow integrated. So you can pick and choose from the best possible solutions for your use case. We are not limiting your flexibility in that regard too. But if you want to learn more, feel free to reach out to us. Next question is from Michael Ninax of TED, our distributor in the US. Welcome. What will most reduce dependence on individual CT experts over the next decade? Deeper automation, integrated physics-based reconstruction, or clearer standards around dose and quantitative trust? In other words, can we reduce the barrier of entry for CT, and if yes, what is the best way to do it? Who wants to take a shot first?
Okay, I can take that. So I would say it's a balance of all of that. So there will be, of course, things happening that makes the work with CT technology easier. So what we can see is that typically the manufacturers try to make or to close the gap between the universities that want to do everything, mainly customize things with the CT system. On the other side, we have the industrial users, and they perfectly want to have a system that is as easy as possible to work with. Maybe also operators that are not extremely skilled. So the software will be one point to really focus on how this kind of technology becomes easier. And also the reconstruction that we can see on the market is improving from day to day to getting better results. So I think it's really a mix of all those points together to come to really a kind of technology that is more open for the main user group on the markets.
Jochen, what would you say as a user?
I would just add this, that maybe if you are an expert and you're worrying about your future, I think if you are familiar with those things and you can handle those topics, this is certainly a benefit. So if you are able to use high-level reconstruction techniques or are aware of those things, how to handle this, I'm sure there will be a job for you. That would be my, if the question was in that respect.
Yeah, I think Michael is rather concerned about the availability of skilled technicians, which is it is a problem because this is high-end technology and it's not easy to operate. But I know, Benjamin, we're doing a lot, whether it's automated loading, wizard guided like setup, or even maybe AI supporting operators to set up systems better and, you know, also compensating mistakes that the human potentially makes, but also AI-guided, let's say, evaluation processes. I think all of this is a major topic that we as a group focus on, from automation to AI assistance. So it's definitely a topic, how can we make it easier for the user? And that is frankly the job of our companies, of diondo,
Right.
of VisiConsult, to make sure we provide you a tool that's very sophisticated but easy to use.
And so maybe we have to add there's one point also where we try to get the first steps into this kind of work, where we learn that there's typically one expert in the company and many other users of the CT system. So we already try to really set up the CT systems in a way that there are different user group levels, where you can really say there's one supervisor who's able to, for example, set up the right settings for the individual scans, where an operator maybe is just able to start a CT scan. So that's the software side, where we try to reduce the levels, that we can really say there's one supervisor. On the other side, it's really a point also to look or have a closer look to this kind of applications, because also there might be reasons to, in some cases, focusing on this closed design, like it's found at a mesofocus source, that has benefits because you don't have to care about filament exchanges, problems with a vacuum if you are not doing the right job when exchanging the filament, for example. So I think it's really a mix of looking on the hardware that is available and focusing on the software development, user groups on the one side, but also making the things easier with wizards and AI to come closer to this kind of reality.
Excellent. And the last question is whether we use lead or tungsten in X-ray systems. Absolutely, we do. Unfortunately, there is no other way to get the shielding that we require. So yes, we have to, until we find a maybe better material to do that. So with that, I want to thank everybody. We had nearly 90 participants, or over 90 participants during the webinar. That is great. We have a little Christmas present for all of you, because we recorded this webinar and we'll send you the recording. So if a colleague couldn't make it, or you think somebody would be interested in this, you will receive the recording. You're able to forward it onwards. You're also able to get a certificate of participation. Please just reach out to the webinar organizer, Nadia, and we'll make sure that you will get one. Probably only the new year, but we'll do our best to get that over to you. If there's anything that you want to learn more about, feel free to send us an email. If you want to learn more about the diondo products, or what we can do for you, how we can support you, our inspection services offering. And with that, I want to thank everybody for your attention, for being here. We really appreciate you, and have a Merry Christmas and a Happy New Year.